Good evening, this is Kavi Priya, Assistant Professor, EC Department. I am going to discuss about the topic eye pattern. So, the quality of digital transmission systems are evaluated using a bit error rate. So, degradation of quality occurs in each process of modulation, transmission and deduction. The eye pattern is an experimental method that contains all the information concerning the degradation of quality. Therefore, careful analysis of eye pattern is important in analyzing the degradation mechanism. Eye patterns can be observed using the oscilloscope. The received wave is applied to the vertical deflection plate of oscilloscope and sawtooth signal is applied to the horizontal deflection plate, resulting in an eye pattern. We call it as an eye pattern as it resembles the human eye. So this is the signal which has been transmitted to the oscilloscope. It is applied to the vertical deflection plate and to the horizontal deflection plate sawtooth signal is being applied. So because of that an eye pattern is get created in the oscilloscope. And this is the eye pattern which is used to determine the best sampling time. It is used to determine the distortion at the sampling time and it is used to determine the margin over noise, zero crossing jitter and slope and the time interval over which the wave is best sampled. Every information can be obtained using this eye pattern. So the interior region of the eye pattern we call it as an eye opening. The width of the eye opening defines the time interval over which the received wave can be sampled without any error from ISI. The optimum sampling time corresponds to maximum eye opening. The height of the eye opening as specified sampling time is a measure of margin over channel noise. The sensitivity of a system to timing error is determined by rate of closure of eye as sampling time is varied. Any nonlinear transmission distortion would reveal itself in an asymmetric or a squinted eye. When the effect of ISI is excessive, traces from the upper portion of the eye pattern cross traces from the lower portion with the result that eye is completely closed. There are three features we can observe from the eye pattern. The first one is the optimum sampling time. The width of the eye opening defines a time interval over which the distorted binary waveform appear at the output of the receive filter in the PAM system can be uniformly sampled without decision errors. Clearly, the optimum sampling time is the time at which the eye opening is at widest. And next one is a zero crossing jitter. In practice, the time signal is extracted from the zero crossing of the waveform that appears at the receive filter output. In such a form of synchronization, there will always be irregularities like a zero crossings which in turn give rise to a jitter and therefore non-optimum sampling times. And next is a time sensitivity. Another timing related feature is the sensitivity of a PAM system to timing errors. This sensitivity is determined by the rate at which eye pattern is closed as sampling time is varied. And if an eye opening is of unity, it corresponds to the 0 ISI. If eye opening is of 0, when eye is completely closed, then the particular signal is completely affected by the intersymbol interference. So the intersymbol interference is very severe. So typically an eye opening of 0.5 or better is considered to yield a reliable data transmission. In noisy environment, the extent of eye opening at the optimum sampling time provides a measure of operating margin over a additive channel noise. So eye opening is given by the equation 1 minus d peak. D peak is a new criteria, we call it as a peak distortion. So the peak distortion is a worst case criterion for assessing the effect of ISI on the performance of the data transmission system. So if there is a zero peak distortion, then the eye opening is of unity. So when the unity peak distortion occurs when eye pattern is completely closed. So that's all about the eye opening. Eye opening is mainly used to determine the characteristics of intersymbol interference. Through the eye pattern, we can find out whether the signal is completely degraded. If eye is completely closed, it means that the signal is completely affected by the severely affected by the intersymbol interference. If the eye is widely open, then we can say that the signal is properly sampled. The signal obeys a proper Nyquist criteria. While sampling, they have obeyed the proper Nyquist criteria. Fs is greater than or equal to twice Fm. So signal is properly sampled. So there is a proper time interval between the signals. There is a proper band between the signals. The signal won't interfere with each other. So there is no ISI. So when there is no ISI, the eye will be completely open, widely opened. So that's all about the ISI. Thank you.